right.
Just give me a minute. I'll tell you when to.
You got it, buddy. No problem.
So where'd you get your like HAAS embroidered face
I
mask?
know.
That's like
I was walking.
fancy. That's like crazy.
Pretty cool. Whoa. Now I can hear myself in my own phone. That's scary. Yeah, I was walking in the entrance today, and one of the guards was like, "Where'd you get that?" Well, I guess we're starting to make them. I don't know. My boss handed it to me.
Nice.
Good to go? Yeah, so, and then Frank was saying, you've got a HAAS logo here, you got a HAAS logo here, just all over the place. Yeah, no,
there you go.
He went live. He's going to give me the...
Okay. Oh, there you go. Hi.
No, I know. I'm just talking away.
Just a few seconds, guys.
Try to break
kicking it on.
Just what you want is your boss sitting in the audience right there.
There you go. There you go.
That's right.
If you can hear us out in TV land, send us your questions. Start posting them now.
That's right. You know, it's weird. Sometimes I feel like this thing is not updating correctly.
Okay, it's 9 a.m. Here we go.
All righty.
Refresh.
Welcome everyone to another Tip of the Day live here in sunny California in our Camarillo studios. It's been a couple weeks since we've done this. What with Demo Day live just a week or two ago. So I know that Frank always starts us off by asking you how you're doing. Mark, how you doing?
I'm doing good. I've got my coffee this morning. We're ready to go. We're waiting for your questions. So start chatting things up. Let us know what you're thinking about.
Yeah. Why don't we get started off here? We've got some questions from previous Tip of the Day lives. RW was asking, I have a VF2 with a side mount tool changer. I run a program with a very long tool. I don't want an accidental tool change. What parameter could I change to temporarily turn off the tool changer? Or maybe there's another way to kind of achieve the same thing.
Yeah, it's funny. So we get this every now and then, right? And I used to run aftermarket tools, the spindle, 80K spindles with the wires, stuff like that. They were awful. And the best way to not do a tool change when you don't want to is don't push the tool change button. Be really careful when you're around the machine. Just be super careful. That is obviously the best way. Make sure you're very aware of what's on the control. Beyond that, we understand the question. On the next gen control, there is a setting 113, I think. And I love the next gen control because I forget all the setting numbers now. In the classic control, I had it memorized. On the new one, I just forget because it's got the search function. So I'll just go to Tool, T-O-O-L, press F1, it'll search through all that stuff, and you'll find all the settings that relate to the tool or the tool changer. And you'll find setting 113 that says Tool Change Method. Right now it's set to automatic because I want it to automatically change tools when I push buttons in my program. If you definitely do not want it to change a tool, because let's say it's really big and it doesn't fit in the tool changer or something silly like that, you can change setting 113 to manual, and it ain't going to do a tool change. So that's one bulletproof way to avoid tool changes. But the real answer is don't push the buttons, right? It's like driving a car. If you don't want to drive into the garage door, don't hit the gas.
That's a great tip. Well, since it's sitting here at the top of the chat, let's go for a super open-ended question next. JC says, hello, coming from software development, I would really like to hear a bit more about the motion control system. How's that for the widest open question we've maybe ever got?
It's fun. We were talking about rotaries earlier, and the way that HAAS does things is unique in that we create our own control. Our motion control system is not built on something, it's built by us, which gives us a lot of adaptability. So, what's that, Frank?
We're getting some chats here that people are saying that they're having a hard time hearing you.
Oh, so we're going to check audio. Check.
We good now?
We got some audio. Check. If you're having a problem with the audio, just let us know in the chat, and we'll take a look at that. You can tell us if it's too loud, too quiet, too crunchy, that type of thing, and we'll work on addressing that. But we make our own control, so it's programmed by us. Years ago, classic control was kind of built in assembly. Right now, the control is built on a Linux.
See if I can get this going here.
Check. switch mic packs.
I'll just yell at you from over here.
I'm now on channel 11. Check, check, check. How's that coming through?
Okay, it sounds up there. We're good now.
Okay, cool. We'll try that for now, guys. Sorry about that. We'll figure that out. If you didn't catch that a minute ago about the settings on the machine, the question was, is there a way to avoid a tool change at all costs? And on the next-gen control, you can go to settings, do a search for tool changer, and you'll find setting 113, which is typically set to automatic. You can see it do a tool change. If you set that to manual, it's not going to do a tool change on you. So if you have some funny, goofy tool that you don't want to run on your tool changer, you can change setting 113 to manual, and that's going to avoid tool changes at all costs.
All right, here's a good one. I'm going to yell really loud since you probably can't hear me.
There you go.
So, Edwin Hen says, I have removed my workpiece from my ST15 wide lathe because I have to measure a tool. I had already milled on my workpiece. Can I recover the spindle orientation?
Well, yes and no. You can. So the question was, he's pulled out a part that's got a flat on it on a y-axis lathe. You got a y-axis
Okay,
lathe.
let's freeze it for a second. Sorry.
Yeah.
Let's switch to a different camera. Let's give it a try now.
You're going to check this one? Oh, because the audio's running through that camera. The audio's not feeding once it's on that camera. We'll try that. So, this camera here. The question was, if you pull out a part of your lathe and it's got a milled flat on it, can you put it back in the lathe and pick it back up? And that's the real question. Well, sure you can, but it's kind of like loading a part on a rotary on a mill. Same thing. You're never gonna get lucky enough to put that thing in if it's got a round fixture. You have to, you have to orientate it. So one of two things. You'll probably want to engage the C-axis, your M154, and then you'll want to indicate that flat until it's perpendicular to the X-axis, and then you'll take that C value and enter that as your G54C work offset on your lathe. And then when you can make out and put it back in, you've got to indicate along that flat, and then set that new C-axis position as your new G54. Sure. Check, check, check. So there's definitely ways to accomplish it. Now that's what if you have a C-axis, but he has a Y-axis lathe, which means he's got the live tooling probably, and he's got the C-axis. So that's the way to accomplish it. If you only had M19 orientation, then you can do that too. You can use an M19 P or R to orientate it, but that's not terribly accurate. You're not going to be able to pick up things perfect with just an M19 orientation. You really want to use your M154 C-axis positioning move.
Good. Sounds good. Okay, let's go back to one from previous weeks. Jake Cartwright 1992 says, is there an M code to override rapids on an ST15?
An M code to override rapids on an ST15. I got an ST20 here. There's not an M code, but there are ways to adjust your rapid overrides. And this kind of comes back to the same thing. Settings on a machine, mill or lathe. If I go to settings and I type in rapid, R-A-P, F1, it's going to show me all of the settings I have to do with rapids. And there's one of them there, setting 21, which is your rapid override lock. That's going to lock out all your rapids. You can limit rapid at 50%. That's setting 10, which is going to slow down everything. So there are settings that allow you to limit the rapids, and there are settings to, that's setting 10. There are settings to keep you from overriding the rapids. That's setting 21. But we also have a new feature if you've got an NGC mill or lathe, which is tied to our G0 rapid command. So if I wanted to rapid across this part, which I will do, now you can see the back of my head here. If I wanted to rapid across this part, I'm going to type G0, G91, X minus 15. That's a rapid move. That should rapid from one side of the table to the other. Right there, 15 inches, that's fairly fast. If I want to rapid back, I can just add an E value. So G0, X, Y, Z, whatever, and add an E value. The E value, when used with a G0, is going to limit the rapid on that move. So if I go G0,
X15, E5, it's going super slow now. So all I did to that code was add an E value, and instead of it going whoosh, it's now going whoosh.
Whatever the whoosh is.
Yeah, and so you can do a find and replace. You can go to Edit, F1, Find and Replace. You can replace all of your G0s in a program with G0E10, or 10 point, and it's going to limit all your rapids in that program to 10%. So there's lots of ways to accomplish this. We got settings, we've got E values on the G0s, not an M code, but it just makes use of the existing G code, G0.
Great. Okay, now this is one I was going to tackle myself, but maybe you're going to have to say it for me now since probably no one can really hear me.
Oh, yeah.
So this is a week or two ago. Aggie170HSS asked, what's the latest news on IMTS and HAAS participation for this year? And, you know, a couple days ago, we found out that IMTS was officially canceled, so...
Oh, so that was a question. The question is, what's happening with IMTS? If you've seen the news, if you're a machinist and you love IMTS like I do, you'll see that the city of Chicago said no. Unless we've got, you know, cures, antidotes, that kind of stuff, we're not going to do any large trade shows like that in the city of Chicago, where IMTS has been held forever. And so there is no IMTS this year, kind of. But there still is in a lot of different ways. Last week we had a virtual demo day. Not a demo day at the factory, but we had a demo day virtually over the internet, kind of like a live broadcast like this. Still at the factory. In fact, it was really, really cool. As soon as you guys get done with this, don't stop watching right now. But as soon as you're done with watching this, go on the HAAS YouTube site, watch that virtual demo day. It is awesome. So they were showing not only the APL, automatic part loader systems for mill and lathe, but they showed the robot integration, the new robot integration on the HAAS control. Now, people have been adding robots to HAAS machines for decades, but what's unique this time around is that they've got this robot mounted in front of the machine, and they're completely programming that thing with the remote jog handle. So that is pretty awesome. So if you know how to run your HAAS mill, your HAAS lathe today, you can run a robot, really simple, just using the VPS templates. And so all that is shown in the virtual demo day that's posted right now on YouTube. So what's going to happen, I believe, now I'm not involved with this necessarily, but there's going to be events like every single day.
I'm pretty sure you'll be involved.
Well, I might be. I'll be involved. Well, we'll see like that. Yeah, we'll see what happens going forward. I'm excited for it because IMTS is one of my most favorite things in all the world. At almost every job I've worked at, I've asked for that time off. In fact, IMTS almost always lands on my birthday. My birthday's September 10th. And so IMTS is usually that week right after Labor Day. It used to be the week before Labor Day. And it's just a fantastic show. And I'll mention this. We were talking about it earlier. I've got some shoes here on the machine.
I was going to ask you, what are your shoes doing sitting on the machine
there? It was because what I was thinking about this week was IMTS and what will HAAS be doing to engage and show all the cool stuff that we're making. And I love talking to the customers, so I love IMTS for that reason as well. But when I first started working for HAAS, I don't know, 8 years ago, we had to wear dress shoes. And so these shoes have a story in that IMTS, when I first started working for HAAS, was a 6-day show. And I complained to my boss, John Nelson, after 2 days. I'm like, I can't walk. I'm literally, I couldn't do it. And so John was nice, and he's like, okay, go put your work boots on. So I'm about as flexible as a saltine cracker, but these boots are the most comfortable thing in the world. You can buy these. These are the Timberland Pro 40044s, the Titans.
Well, you know it well.
I bought these for a lot of years. They're so comfortable. So John let me wear those shoes. But in years following, I got the Bostonians here, the Bostonian Flex Lights, and they're so thin and light, but I can walk on these things for a month. But until you find the right shoes, you hate IMTS. Worst show ever. And once you get the right shoes, though, it's a great show. And so this is an opportunity for us to give you the show without sore feet. And I know years ago,
that's a good way
that's all I can think of.
Yeah, we will definitely be doing, the tentative plan is to do content every day of those 5 days that you can normally be at IMTS. And We're going to bring you everything we could possibly think of from the factory. New machines, you know, cool tips and tricks. For sure, we'll have some tip of the days in there. It's going to be good.
Yeah, we'll be engaging, and if you have an idea, something you want to see, shoot it to us, right?
Exactly.
In the comments right now, or shoot us an email at tod@haascnc.com, tod@haascnc.com. We'll look at those ideas, but we will definitely be engaging just every day. And again, we're doing that now with these live because of the situation with social distancing and stuff. We're here live answering your questions. Ask your questions right now. We'll answer it right now. In a couple weeks, we'll be showing you another virtual demo day from HAAS, so keep checking the YouTube channel. And we're just not going to stop. We're just going to keep sending out information.
Not gonna stop. Okay, so let's jump on to another question from a couple weeks ago. Ward Jamaif asked, can you do light 5-axis simultaneous surfacing with the T5 series of indexers? Or does it do only 3+2?
So that's a really good question. And if you're looking at a machine, you've got to ask that question. So if you understand, I'm looking for a part. 1 second there, I'm going to grab a part. I'm going to walk over here. I'm going to open up a gate. And I'm going to grab a part.
Wow, luckily you knew it was in there.
This is a part.
Oh.
A part. So this is a 5-axis part. Now, if you're buying a machine, and just because it has a rotary doesn't mean that it's simultaneous 5-axis. You might not be able to do a simultaneous 5-axis cut in all 5-axis or 3-axis at the same time. Some machines are only 3+2, which means it just rotates, you do your thing, rotate, you do your thing, which is good. But on almost every HAAS rotary out there, you can do simultaneous 5-axis programming. That's why people love the HAAS rotaries. You bolt them on the table, you can do simultaneous 5-axis work. In fact, I think the only rotaries that we make that only index are kind of on some of the bigger machines. We have indexers, like a 5-degree indexer on an EC1600, some things like that. We had indexers. But on almost every small rotary product that we've got, you can program that axis simultaneous combined with every other motion, and you're going to be able to do whatever you want. Even on our little guys, the little TRT-70, full simultaneous. So it's all built right into the control. So you don't have to worry about that.
Right, the answer is yes.
The answer is absolutely yes. But when looking at a machine, be careful, because a lot of manufacturers don't do that. A lot of manufacturers, you buy a 5-axis machine, and it's not a 5-axis machine, it's a 3+2. It can't actually run those axes at the same time.
Right. Okay, so we have a couple, we got an interesting one from Alexander Teodorovic. And he says, please send greetings to Misha and the Rotary Department. And funnily enough, I used to work hand in hand with Misha every day it was probably 15 years ago now, but I'll tell him that you sent your greetings. Still hard at work making every conceivable kind of rotary product that we make there at HAAS. He knows all the ins and outs of every one that we've ever made. And then right after that, we've got Usren May asks, hey guys, my shop has been closed since the pandemic. What should I do before I get my VF2 back up and running? And the answer to that is we made a short video about preparing your machine to start up after it's been idle for a little while. And I'll put a link to that video in the description for this video when we get it live when we get back to the factory. But we have some other similar videos on getting your machine up and running after it's been idle for a while. So yeah, we'll put links in the description for that. Let's move on to Martin Lawrence. Why don't we?
The Martin Lawrence.
Yeah, I don't know if this is the Martin Lawrence that most of us might be thinking of.
I'm not making fun of anyone's name, by the way.
That's right. No, it's a
you
great
will
name.
not hear me make fun of anyone's name.
Okay, is there a reason HAAS stopped the ability to use Q values to Peck tap in G84? I used to use it in an older control, but I can't use it on newer controls.
So I've been
wondering if has it existed?
I don't know that we ever did it that way. We made a video. So my take on all things programming is, as long as there's a way to do something, I'm thrilled, right? But there's always some things we can change with the code. So we made a video on Peck tapping. Just go to YouTube, type in HAAS Peck tapping. You'll find an entire video on exactly how to Peck tap on your HAAS mills. And so we've got that covered. Now with that said, we are adding a Q value to the G84 pecking cycle. An enhancement has been added, and so you'll be seeing that in the code in the future. So we can take a look at that. So it's not going to be there in older, especially classic HAAS controls, but you can absolutely do it. There are a million different ways to accomplish Peck tapping on a HAAS machine. So check out the video. We've got 10 minutes on nothing but that subject.
And then you were even saying at the same time, it looks like perhaps this is something that may be added to the software in the coming iteration.
So that's going in there. The enhancement request is in there, and it's got weight behind it from questions like this. That's kind of how we get enhancements pushed forward. It's customer requests. A lot of the things that happen on the HAAS control are because customers think it might be useful. So they make suggestions, goes into control, works its way through the system. All right.
Here's a good question from that's pertinent for where we are with HAAS Tooling. GeneX31 asks, when comes HAAS Tooling in Europe? And the short answer is sometime to be determined. Right now, we're just about done with our implementation selling here in California. There's a bunch of things to figure out, tax issues and all that sort of stuff. So on July 1st, we're going live nationwide. And actually on our next demo day live, that's going to be probably the center focal point of the entire presentation will be around HAAS tooling, every kind of tooling that we're going to be bringing you guys, how easy it is to use and how much you can save. All great information, but following that, at some point the plan is to certainly expand that to Europe and the rest of the world.
Yeah.
And that's about all I can tell you at this point. Let's move on to, okay, Slugs asks, this is a week or two ago as well, a machine like a DM2 where the anchor kit is almost mandatory, does it require more concrete or is it more heavy cut related? And we were having a little bit of a discussion about this. If you go to our website and you look at the requirements, the machine requirements for installation, you'll see that the requirements for a VF2 and a DM2 are exactly the same. We recommend a typical 6-inch slab, just like you would in most industrial areas. And you don't have to do any additional coring or anything like that. You do certainly want to anchor a DM2. And it's not because of heavy cuts, it's because of the extreme acceleration the machine has.
Yeah, it's fast. So,
that?
Yeah, that thing's pulling well over a G and acceleration type thing. So it's a sewing machine. It goes really, really fast. That's a great machine, by the way. I like the DM2 because the DM, right? If you guys don't know it, we have a DT1, DT2, which is super fast, right? It gets in there, gets things done, and it's got the BT tooling, like a BT30, smaller tool on it. The DM models take the exact same Cat40 tooling, SK40 tooling that you would see on a VF2, and it works out just fine. So you got the bigger, beefier spindle in this thing, and it's a table that's moving anyhow, and so you have the kind of the best of both worlds with the DM. But yeah, because it's moving so fast, it's definitely helps with anchoring that thing down. And even on a VF2, it's only going to help. When you use the bolt down kits.
Cool. Okay, so another question from Edwin. Sorry for my name, Edwin. That's fine. I just said it wrong. Sorry about that. I am from Holland. Do you know why the feeds and speeds that tool manufacturers give are way too high for turning and milling on a lathe? And that's an interesting question. I mean, sometimes it seems, I just know in my limited experience compared to you for sure, sometimes it seems like the kind of sweet spot number they give you is maybe even too low. So there's probably variation across the whole spectrum, really. Yeah, right?
it really depends on what parts you're running. So on a lathe, it all comes down to the material that you're running and how long that material is, how far it's sticking out. The feeds and speeds might be under perfect conditions, which means 1-to-1, which means I've got a 100-millimeter block sticking out, it's 100 millimeters diameter, and those feeds and speeds are probably based on that. So they're saying perfect condition. You're always on a lathe turning into the chuck, not facing it right. You want all that pressure going into the chuck. That's how you get your aggressive feed rates. So if you're running a short part, stout, and you're taking those recommended feeds and speeds and driving it straight back into the chuck, you're probably pretty good with the recommended feeds and speeds. Now, as your part hangs out, you're going to come into chatter and this type of things, and that's just one of the innate problems with sticking parts out in space that are bouncing around. You might have to use a tailstock. You made video on that, fantastic video on that. You might have to adjust your speeds and feeds. And remember, sometimes if you get into trouble on a lathe with some type of chatter or this type of stuff, slowing it down is not always the answer, especially on softer materials, aluminum, that type of stuff. You might need to speed it up to get yourself in that sweet spot. Sometimes if you're getting into problems, you need to increase your depth of cut. Remember, if you're working on harder material, you want to be on the nose radius of that tool. You don't want to be taking just a small, tiny little cut. So if you've got a 0.8 millimeter nose radius on your insert, like a 031 nose radius, number 2 nose radius on your insert, you don't want to be taking a 5 thou depth of cut. That's too shallow on hard material. It's just going to rub. You're going to put a notch in your insert. You need to bring that thing down where your depth of cut is at least maybe 2/3 the nose radius on the insert that you're using. And if you're getting into trouble with other chatter stuff on a lathe, bury that sucker. I mean, if you're running a CNMG 432 or a CNMG 120408, and you're gonna run across that sucker, you can go 1/4 inch deep with those inserts. Sometimes if you're only gonna take a 1/4 inch overall depth of cut on the lathe, and you just can't get around the chatter or something like that, instead of going 1 millimeter deep per cut, take 6. The insert can handle that. Just slow down your feeds and speeds to adjust that. You'll make up for the time in a deeper depth of cut. Make sure you're pushing it at the jaw. Your chatter will go away. So there's lots of cool things that you can do to make up for any problems you're having. But no matter what you're doing with machining, lathe or mill, the recommendations are just that. They're just recommendations, and they're usually best case scenarios.
Yeah, rigidity of the machine, rigidity of the work setup, all that, how far your tool's hanging out, all those things are going to affect that. I mean, it's, endless variables, of course. That's why it's so hard to make recommendations to begin with. So kind of along the same lines, Chris Kearney asks, I'd love to see a video someday about designing cuts to produce easily augured or conveyed chips. For example, when face milling aluminum, you can make tons of stringy chips, or similarly during drilling. Now, that would be kind of an interesting video, and it's along the same lines, what insert are you using, how's the chip breaker work, all that sort of stuff.
So we made this cool thing. So we were just talking about an E value, E as in Edward. Adding an E value to your G00 code if you want to slow something down. If you've got an engine block on a big rotor in your HAAS and you don't want to go in whoosh as it flips between operations on your HAAS, add an E value, it'll rotate more slowly. Now if you add an E value to your G81 drilling cycle, it'll actually spin the chips off of that tool. And we made a video on that, so check out the stringy chips video on the HAAS YouTube site. And so we've got some little tricks up our sleeves on how to take care of those stringy chips. Of course, if you've got stringy chips, the best way to get rid of them is to increase your feed rate. You want to bump up the chip load. You want to try and break those chips any way you can. Sometimes it's just unavoidable with the material that you're cutting.
Right. Okay. Fresh in from Captain the Pea Farmer, he says, Mark, exclamation part. What are the right steps to take after crashing your OMP40? That is after changing your underwear, of course.
Oh, man.
And that is exactly what happens. You see it jet out of the...
oh, no.
That's what I like to do. I like to hit tool release and then throw that thing directly into the table. That's my favorite move.
Oh, man. So the question was, again, you've got a probe in the machine. That's our OMP40 or OMP40-2, our spindle probes. You crash the sucker, what do? You kind of do the most basic thing. You buy another probe tip, and so I think we sell them, Renishaw sells them, you can buy them, the ceramic tips. Now the nice thing about the ceramic tips is that they should break before any serious damage is done to the probe. That's why you spend the extra money for the ceramic tip. You have the ruby tip and then the ceramic white part, and that neck is meant to break. So all you have to really do is change out that tip. You'll have to run through the calibration process, and part of that calibration process is adjusting the 4 set screws on the side of the probe, sweep it back in, make sure it's dead on center, then run the calibration process again. If you've done that, and you've calibrated on a ring gauge, right, 25 millimeters or 1 inch ring gauge or whatever you're using, you calibrate that probe. When you're done calibrating it, after you've made sure the ruby tip is on center, then go ahead and probe that same bore. Go into VPS, run the bore cycle, and go beep, beep, beep. Look at the diameter it says, and if you just calibrated a 1 inch ring gauge, and then you go to probe that bore, and you look at the macro variable, the 188, 189, that type of stuff, for the diameter, it should read 1 inch. If it doesn't, something's gone terribly wrong, and you might have a problem with your probe. But if you calibrate the probe, you change the tip, calibrate it, and then measure a ring gauge, if you're getting the right size, then you're good to go. I wouldn't worry about it. You just move on. Shouldn't be a problem at all. If you've actually cracked the case or this type of stuff, then you've got to give Renishaw a call, and you can talk about a replacement program or getting that repaired.
Good one. Okay, this is from several weeks ago. TCF Precision Machining asks, is there a way to lock out the probe length offset in a VMC next-gen control?
Oh.
I know you can lock out all the offsets, but I hate accidentally modifying the probe length offset.
Yeah. So I was job shop for a lot of years, and so I'm changing the tools out of my machine every day. I mean, everything. The whole carousel dumped and new tools coming in. And the way that I start my setups, the first thing I do is I go to the tool offset page, I press origin, and I clear out all my tool offsets. And then I would immediately wipe out my probe length offset. And then go, damn it, and then, whoops, can I say that? Yeah. So,
it's not that bad.
So, yeah, there you go. So I would wipe out my tool length offset for my probe. Now on this machine, my probe is set to 25. On our UMC, it's set to 41. On the tool offset page on a next-gen control, you can define what type of tool it is. You can set it to, number 1 is a drill, number 4 is an end mill or a shell mill, 3 and 4. Number 7 on the far right of that list, you can set the tool type to probe. That's super important for this reason, because when you go to the tool offset page and you press origin to wipe out all of your tool offsets, it's going to ask you at the bottom of that list, it's going to say, hey, do you want me to wipe out all tool offsets or wipe out all tool offsets except probe? And because we told it what type of tool type it was, we told the control that it's a probe, it's not going to allow you to wipe it out unless you manually go in there, go down to that tool offset and origin it out. It's not going to let you do it. So make sure you set your tool type as probe for the probe, and then when you origin, it's going to come up right there on the screen. Do you want to wipe out your probe tool length offset? And you should say no.
That's all right. Pay attention to that.
Yeah.
Okay, here's an interesting one. This is from Devesh Gulahar. Is there a difference in the quality of machines made for the US and the one made for India? And I'm assuming that's HAAS machines. And the answer is absolutely not. All of the machines are made in one factory right here in California, about, 5 miles down the road in Oxnard from where we are here in the studio. Every machine rolls off the same production line, no matter what machine, what type of machine you're making. We're making lathe, mill, HMC, all comes from the same factory. So
there might be like different package models. They might have a promotion in your neck of the world, and that doesn't mean it's a different machine. If you get a certain model in a certain country that you're in, that just means it has a certain combination of options on that machine. But there is nothing different about the machine. Completely the same. The only differences between one machine and the next that might change is if you buy it with a metric or inch turret, or a metric or inch, a BT or a CT spindle. That type of stuff. Aside from those things that you tell us to change on the machine, identical.
Yep. Okay, let's see. Maybe this is just required. I should just say the question instead of prefacing it with anything. JC asks, can you guys show how you would probe a shaft on a rotary table VF3YT? Maybe just a quick description of it, I suppose?
Yeah, so probe a shaft on a VF2YT. So you've got a VF2, VF like this. It's a YT model, which means it's got extra travel in the Y-axis. And I'm assuming that they've got a shaft going sideways. So how do you probe that in the Y-axis? It's not that tough. You'll just use the VPS templates, and we have one called Y-Web. This is not a round shaft, but if it were, this is not round either, but it's close. So if I was going to probe this, if it wasn't tapered, if it's tapered, it's not quite as easy because it has to be perfectly parallel to the x-axis. But in normal situations, you've got a bar in there. You don't have to probe at the zenith of the part. It might help, but all you have to do is jog along the top of the part, use the Y-Web option under VPS or even the old VQC templates, and it's going to come in and probe the front, probe the back. You're going to find the center of that bar pretty simply. Now, do not probe the Z until after you've found the Z, the Y-axis center line. Otherwise, you won't be probing the very top of the part. You'll be probing something other than zenith. You'll be off center. So always probe the Y web first, beep, beep, beep. In that case, you don't have to be perfectly at the high spot. Like if you were using an indicator, I might just indicate the high spot. But even if you're on the rampy angle, it's going to find the center of the bar. After you find the center of the bar, go to G54Y0. Then reprobe the top of that round thing, and you'll have all the information that you need. So it's all right there in the templates in VPS.
Cool. Okay, now we got talking about this one for a little bit, and I think you have a great answer for it. So let's just get into it. Javier Godacito asks, please talk about the limitations of the ST30Y, G0203, XYZ, CR don't work. In live tools, the G99 only works in the main spindle. And after we had the discussion, it really comes down to how HAAS chooses to do things and allow you to program on a lathe.
Yeah, so I've run a bunch of different machines, different machine models, stuff like that over the years, my first shops and that kind of thing. And everyone does something a little different. And what HAAS has done with the lathes is unique. When I first walked up to the HAAS lathe and I wanted to program on the sub spindle, secondary spindle, right? Not the main spindle, but the secondary spindle. I was confused because what I was used to in the past was having a different G code for the sub spindle than I did for the main spindle. So if I had 50 G codes for this side, I had 50 more that I had to memorize or look in the manual and relearn for the sub spindle. HAAS doesn't do it that way. And so the question is saying, why can't I program a G98? G98 on a lathe is different than a mill. G98 on a lathe is feed per minute, you know, your inch per minute or millimeters per minute feed rate. Typically on a lathe, you'll program in G99, which is feed per revolution. And you can't program that way on the sub spindle directly. But here's the catch. You shouldn't be programming directly on the sub spindle anyhow. You're missing the point if you're programming that way. On a HAAS machine, they've made it so amazingly easy. And we're definitely not going to change this. I hope we're not changing it ever. Because you program the part as if it's on the main spindle. Really easy. I've got all my programming here, tapping, turning, everything. You know, boring operations. I write the program for the main spindle. And then all I've got to do is put a G14 in front of that code, and it flips it all, kind of mirrors it all along the Z-axis, and it runs it on the sub spindle. Super easy. It just doesn't get any easier than that. That was helpful years ago, especially when people didn't have perfect post-processors set up, where they had to rewrite, and you had to pay $1,500 to have all the codes that were working fine for your main spindle rewritten for the sub spindle. So you had to have these special post processors to get your lathes to run if you had a sub spindle. On the HAAS machine, it's just super easy. Your post processor changes one thing. Add a G14 and it all runs on the sub spindle. Now there is a caveat with that if you're doing this right now, is that if you're flipping this thing from one side to the other, your tip direction needs to change. The machine still needs to know that, let's say this is tip direction 3, you've got to change that tip direction to reality. So you've got to change that to whatever you're running here. So G14 makes sure your tip direction actually matches your tool, and you're up and going. All the codes work perfectly, and so it's just too easy to program a HAAS lathe on a sub spindle.
Too easy. Okay, here's a fun one. Francisco Acevedo asks, getting a VF4 with a pallet changer. Any advice or anything new I should look for? Never used a pallet changer before.
Oh, it's awesome.
All the things you could do, right?
Yeah. Yeah, it's incredible. So it's for any type of pallet changer, it doesn't matter if it's on a vertical or a horizontal. It's all about the fixture. It's always about the fixture. So you want to get this thing to run reliably. You don't want to be talking about earlier. You don't want stringy chips. You've got to get your feeds and speeds down right. You've got to get the cutters right because you don't want stringy chips. You don't want chips building up. So you want to make sure that all your coolant is set up properly. You might add air blast to the table, this type of thing. You can even buy a little fan that blows off all the chips before it comes out of the machine. And besides that, you just want to load up that table. The more parts you can run at once, the beauty of a pallet changer is that the thing will run by itself forever and you don't have to walk by it very often. And of course, same type of thing, I love the probe. If you're running 100 parts at one time, you don't want 100 bad parts at one time. So for me, I'm definitely buying a probe because I want to come in and maybe check that drill before I run the tap, make sure it didn't break if I'm running some hard materials, or I'll want to come in and probe that one part before I run it to make sure things are fine. Also with a pallet changer as opposed to a normal setup. On this machine, if I'm running a part, I might just probe my corner of my part, call it G54, and I'm done. If you're running pallets, you're going to get really good at a code called G10. So you're gonna want a G10 and write to your work offsets, because you're going to have a different work offset for pallet 1 than you do for pallet 2. And you'll use a G10 to write to those work offsets. So if you have a VF with a pallet changer coming in, grab your manual right now, open up the book, look at that G10 code, and make sure that you're able to write to the work offsets, because in your G-code program, you're going to write to the work offsets differently for one pallet than the other, typically.
Cool. Okay, so this one here on the chat from CNC Ukraine. Hi, HAAS Connect app does not support Cyrillic symbols. Same situation with the uploaded programs. If we have Cyrillic symbols, name, comments, etc. in there, they will not show up. And I don't know what the answer to that is.
That's a good question.
But we'll definitely bring this up with the software guys and the translation guys, I suppose, when we get back to the factory. So that's noted, and we'll check into it for you. Next up, we have GNX31 asks again, what is the minimum diameter you can drill in a VF2SS?
Minimum diameter you can drill on a VF2SS. As small as,
is there a point at which a teeny drill is going to break?
No, and so there is, I guess, in theory, but in practice, you just have to run it and try. So it's almost more about the tooling than anything else. If you're running a very tiny drill, you need a tool that's got very little run out. It all depends on the material, how much coolant you've got, this type of stuff. Usually with the tiny drills, you're probably going to want to run some type of high-speed drill that's got some flexibility to it, if you can, so it's less likely to break in the material. But no, yeah, we've got people drilling with 20 thou drills, 0.5 millimeter drills all day long on VFs. But you definitely don't want to just chuck it up and whatever ER call it. Like if you're getting into this little tiny stuff, you need just the right holder with very little run out.
Put it in a Weldon holder?
Put it in a Weldon holder, yeah, side lock holder. It's as much about the tooling, the drill choice, feeds and speeds. You can't run the thing fast enough, so you'll want to run that thing as high on RPM as you can in most situations. But like anything else, check your coolant concentration, make sure it's rich. If you can, get some TSC going around that thing through the collet. But no, we have people using circuit board drills and small drills all day long. But the secrets usually come down to material-specific questions, what you're trying to drill.
Cool. Now here's a question from a couple weeks back. Y Chef asks, I've been wondering what type of tool compensation you guys use and how you use it in conjunction with tool diameter probing. Can you update the wear table instead of diameter?
Short answer is no. So the question is, can we update the wear table instead of the diameter? It's something we've looked at over the years. Right now, I've ran some machines where I'll go into the Renishaw macro, I'll change a couple variables so it, when you probe a tool, let's say I've got a 12 millimeter tool and it measures at 12.05. So I don't want it to put 12 millimeters into my diameter. I want it to put 0.05 millimeters into my wear. Right now, that's not the way we run our probing cycles. So there are custom Renishaw cycles that you can create, and you can go on the internet, look for that can do what you're asking, but right now that's not the way our cycles work. But it's come up a few times. It might be something that we'll look at. And again, I've messed with the Renishaw macros and accomplished that. You can send me an email, tod@haascnc.com. I'll tell you what we know, and it's always possible. But in general, I don't like any system that completely changes the basic way a machine works, because it just confuses operators. So if your shop is so custom, you're gonna have to really train every operator on why your machine is different.
Speaking of macros, Michael Sobirajisk, I guess, totally murdered that, sorry, asked which macro would he use for an M30 counter?
So on the M30 counter page, again, you can go on YouTube, check out our timers and counters, or customizing your HAAS control.
Whole video for that.
Yeah, exactly. So we've got a whole video on that.
From a long time ago, too.
Yeah. So it's really kind of cool. There's some settings on the control. If you type in M99, it'll say M99 bumps M30 counter, but what is the M30 counter? As far as a macro variable goes, it's pound 3901. So we've got two M30 counters for you that you can use, and they're separate from each other. 3901 is the only one I remember. I don't know if it's 3901 and 3902 or 3900 and 3901. We could check it out, but if you're going to write to a macro variable, you could say 3901 equals 3901 plus 1. Then every time it reaches that macro, it's going to increment the M30 counter 1 on your control. And so it's right there in the macros list. It's pretty cool. You'll want to watch our other video that talks about limiting look ahead, because if you have a program, it might look ahead in the program and bump that counter before you really want it to. So you'll put a something that blocks look ahead before you run that pound 3901 equals pound 3901 plus 1 code. A backslash or a forward slash also blocks look ahead. I like using that in my macro programs. But again, check out the YouTube site and look up the video that talks about customizing your HAAS control. We've made an entire video on that.
And interestingly enough, Y-Shift just added to the chat, oh man, you guys answered my question twice now. Wow, thorough. Thank you again. So we were talking about that earlier, whether or not if we ask the same question repeatedly, would you give the same answer? And the answer is not quite, right?
Probably different answer every time.
Yeah, I apparently didn't cross off one of the questions that we asked before. All right, so there's a, we certainly can't go through any one of these without having some tool offset questions. So Norbert St. Pierre says, is it possible to set all the tool heights off one tool, then just set that one tool height when changing jobs?
Yes. So we're looking at that. We've got that on a video. We'll take a look at that. And so we're going to make a complete video on that. We're looking at making some enhancements to the control as well. But generally speaking, we've got a video that talks about setting your tool length offsets and your work offset Z length offsets. Take a look at that. In that particular video, we show us setting all of our tool offsets off a certain position. So I've set all my tool offsets here, touched them all off, whatever, with a touch off tool, piece of paper, a shim, a 1, 2, 3 block. Once you've set that position for all of your tools, then every time you add another part that's at a different location than where you touched off those tools, you need to measure the distance. So we would measure the distance between where I touched off the tools and where I'm now going to run my tools. If this is my G54 and my G54 top of part is 2 inches higher in the Z than where I touched off my tools, then we'll just take one of those tools, touch it off here, look on the screen, see that it's 2 inches higher, and that will be my new work offset if you're touching off manually. So my G54Z value will now be 2 inches. Where the 2 inches come from, that just means that my present G54Z work offset is 2 inches higher in the Z axis than where I touched off all my tools. There's a bunch of different ways to accomplish that depending on how and where you touch off your tools, but it all comes down to that same thing. So check out the video that explains how to set your tool and work Z offsets, and you'll see a portion of the video that shows this same Heimer, because this only comes up, of course, if you're touching off tools manually. If you have a probe, you don't care, because you're touching off all your tools in the probe, and your probe just comes in and sets all the work offset, and it does all the math for you. But if you're setting things manually, you can take the Heimer 3D sensor or a regular indicator, indicate the difference, or just touch off your tool here, and then touch off that same tool here, measure the difference. That's your new work offset Z.
Cool, that's it, right? Okay.
That's it for that. Take a look at the video, yeah.
I'm not sure. Let's see. Jose Ruben Hernandez asks, Isla asks, can we have a word about oil skimmers? I process cast iron and my HAAS smells real bad on Mondays. I can add a little bit. You know, I was part of a little bit of the testing that we did on the HAAS oil skimmer, and from my experience, they work really well. We use them on a number of machines in our own factory where we're processing cast iron all the time. So that I can certainly vouch for how they work. Anything to add to that, I guess?
Oh yeah, so if you've got, there's different types of oil skimmers out there. Most oil, right, doesn't like water, it floats to the top. And that's the way most oil skimmers work. They simply, they drag something through the coolant, it comes out, you pull the oil off the top of the material. If you've got an emulsion type coolant, it, to a certain extent, is going to absorb some of those oils. And it's going to wrap it all up into the coolant itself, which means it's never going to float to the top. And so the more oil that you've got in the system, it's going to kind of degrade your coolant. It's not going to do exactly what it needs to. So if you're running a lot of bar stock that's muddy, it's got the terrible oil on the top of the bar stock, and you get more and more oil into the coolant. The longer it sits, like over the weekend, that stuff will float to the top. So generally just leave that skimmer running all weekend, and it should get out all the big stuff that's floating on top.
Okay, sorry, here I go. Back on camera.
Got some more there.
Okay, again, one of the questions came in from off camera. Stein R79 asks, what is a reasonable amount of downtime to expect when you upgrade to an automatic parts loader on my lathe? My machine is ready for automation. And I'm not going to give you an exact number, but we're probably looking at about 2 days. Probably a day for the installation of the APL and another day to get up and running programming it.
Yeah.
That seems pretty reasonable, right?
Yeah, it's not bad. Because it's integrated into the control, if you know how to run the HAAS machine, you're already halfway there. All the screens are going to look familiar. All the templates are pretty straightforward. Just wants to know how many parts you have. We've made terrific videos on that. But yeah, I think 2 days is a reasonable amount. So a day of messing around with the install and a day of playing around, setting it up and getting comfortable with the interface, and you're ready to go. And of course, you could say it takes an hour, but you want to play with it. You're going to be playing with this thing, but certainly a day of messing around, if you already know how to run the lathe or mill, is plenty.
Yeah, I think that's pretty reasonable. Let's see. Let's go for another wide open one. Why not? Klopako, this is from a couple weeks ago, asked, hi, can you explain how G150 works?
G150 is cool. I like G150. So the only people using G150 are the hand programmers. Obviously, if you have a CAM system, you're going to be using the CAM system. If you've got a pocket like this, I did this thing with a CAM system, pocketed out around this. What's unique about this pocket is that it's got a big boss sticking up in the center. G150 is nice. All you have to do is define your perimeter shape. And you can do that, and they'll have a P and Q value, kind of like a G70, G71 cycle on a lathe. So it's a subroutine that defines the shape of the pocket that you want to machine. Once that's done, you answer the variables, and it machines it out. If you're machining out a pocket that has no bosses, no islands in it to avoid, then that's it. You just define your perimeter, and you're done. If you have a boss in the middle, you have to get used to how the G150 cycle works. Essentially, I don't know if you can see this. It's really easy. We should do a video on this. And so if I was going to do that exact same pocket with a G150 cycle, G150 is super easy, basic. But when you add a pocket to the middle, if I wanted to create this, then I define my 4 points. That becomes my perimeter in the G150 cycle. If you added in another boss that sticks up that you want to avoid in the middle of the G150, you have to be clever with the way you do this. So you might have to come in, because you can only define one perimeter, one contour in the G150 cycle. You can't define this one and then an avoid cycle. You only have one defining contour. So in this particular cycle, I might break this here. I might start this here, come here, break this here, create another line here that comes up and comes over and then down, or I might even create an overlap here where this one comes over and then down and then back over and then comes up. So what you're seeing here is that with the G150 cycle, the only thing that's really important that you're going to have to get used to if you're using it all the time is that, just remember, it likes one continuous defining contour, and so you've got to define everything with one single contour. And so even your bosses, your pockets have to be built this way. That's the only weird thing about it that you have to get used to, and then you're all set. But so the cycle is meant for one pocket, not one pocket with 20 islands in it. If you're doing that type of thing, that's a lot of work. I'd say you start moving towards a CAM system. There's also cool cycles on the machine itself for those type of pocketing routines.
Sorry, losing my place. trying to
He's
find,
used to me talking for half an hour.
Yeah, exactly. You could go on for so long. I feel like I can be lazy here, I guess. So back to main spindle, sub-spindle stuff. Alex Resler asks, we have a DS30Y, and I have tried the G14 spindle swap. For the most part, the program does transfer. However, if I want to, I guess, transfer a C-axis command, I have to use an M119R value, it looks like. Is that normal for the sub-spindle?
So he's doing something different. He wants to orientate the spindle perfectly. Yeah. So with the orientate spindle thing, I think if you use an M19, there might be an issue with that. I'll have to look it up and see what's going on with that particular case. Why can't you just use an M19, R180, and then put a G14 in front of it and have it be the same as an M119, which is the spindle orientation command for the sub-spindle, R180. So we can take a look at that. Getting all those things to line up perfectly is unique. Plus, you have to remember that the spindle's going different directions. On this one, an M3 is this way. On this one, an M3 is this way. And so there are some funny things there. On that particular case, shoot me an email, tod@haascnc.com, and we'll take a look at it and we'll kind of get to the bottom of it, see if there's something weird going on or if it's just the way that we're programming a particular operation. But you can actually, you can line up the C-axis, which C-axis is like a rotary on the lathe. The spindle is not spinning round and round. It's working like a real rotary. And you can align the C-axis to the M19P0 orientation. And so where all those numbers meet up, you have to understand that if you're trying to do perfect handoffs. But it gets complicated. Make a great video. We should make a video on spindle handoffs, right? So G199 spindle sync, spindle handoffs, how those P and R values work with the M19 and M119. That'd make a great video. And it's fun to watch. It's so sexy. So if you bought a new DS,
watch it even if they don't need
oh
to learn
man.
it.
So this is not for the customers out there. This is for any HAAS applications engineers that are installing a machine. If you've got a customer with a DS and they're running this thing for the first day, oh, for sure, you've got to, on the very first day, run a spindle sync and have it do a part handoff for them because it'll make their day. It's just so sexy. It's so cool. You want to see that spindle come in, whoosh, right, with the 3 jaws. And you orientate those guys, set those guys, so you can even have them mesh, right? So they'll interlock. We're like, oh no, they're going to crash. And at 2,000 RPMs, this thing's coming in. Then it does a part handoff, comes back and spins. All that stuff is controllable. And so if you're an apps guy, do the customers a favor. Make sure you're showing them that part handoff on the first day because the customer will think it's cool. I think it's cool.
It is always cool. We're probably going to wrap up here in a minute. We've been going for almost an hour again. Thank you guys for tuning in. We're at like 230 plus people on the stream here. Thank you so much. Let's wrap up with another maybe basics one. I have it here on my note as well. Nandika Sirin Awan, sorry, I murdered another name. Do you prefer using G53 or G28? Please explain.
Yeah, so we made videos on both lathe and mill for that, G53 and G28. Recently we had a question about what to use, if it's G43, G44 for tool touch-offs. And I said, really, G44 is the code if you want to crash your machine. There's no good reason to use it. I know we've all seen the t-shirts that say there's no place like G28, G0, Z0, right? Or there's no place like home. That code on all of those t-shirts, G28, G0, Z0, will crash your machine, right? So if you got that t-shirt and your machine is toolbox, you've got to add a G91. There's all kinds of bad things that happen with G28. It's kind of an antiquated code that was necessary back in the good old days, and it just doesn't do what most people think it does. If you command a G28, G0, Z0, it's going to move to Z0 in the currently called up work offset, which might be G54. It's going to move to G54 Z0 before going home, which means it's going to crash into something probably and then go home safely, which makes no sense. So my recommendation to you is mill or lathe, do not use a G28. There's just no good reason for it. I'm sure there is a good reason for it. I've just never, the calls that I get are, hey, I just crashed my machine using a G28. Why did that happen? And so the easiest way to avoid that is stop using G28. Just go ahead and use a G53, which is a real machine home position. When you call up a G53 Z0, it's going to go where you think, right back to machine home, not some other place first and then machine home, which no one is expecting. So we've made some videos on that. Just Google it, HAAS YouTube site. home, G28, and you'll probably find those mill-related videos.
Great. And so I think we'll have that wrap up our presentation for today. Everyone, thank you so much for joining us. We'll probably be getting in at least one more of those before the next demo day live on July 1st. I think we can fit one more of these in there. I'm sure everyone online would like that. So thank you everyone for watching, and we'll see you in a couple weeks.
Yeah, so again, right now on the chat, even if this chat is being recorded and you're watching this saying a week from now, put in your question into the chat. Add that to the comment section, and we'll wrap that into the next live tip of the day.
When we come here 2 weeks from now, it'll be on this paper most likely.
Yeah, we pull it up. So keep asking your questions, or you can email it to us at tod@haascnc.com. Tip of the day without the tod@haascnc.com. Send that question through, and we'll probably pick it for the next live. That's it. We'll see you guys later.
Thanks, guys.